Good morning. Sometimes I can't tell what's happening. Okay, now it's working. Good morning. Hello. Hi, guys. Happy Wednesday. So I read that Mr. Post is reminding you to register for the ACT, so do that. This is your secondary reminder. That's super important. Register for the ACT. I know you want to take it really bad, so just kidding. Also, because I was being harassed this morning, I am only teaching, I'm teaching the same classes I taught this year. Next year, as far as I know, I'm teaching ACT Math and Secondary 2. So if you're registering for classes, Secondary 3 will be taught by Belaich, and she is also teaching, um, she's also teaching calculus. Sorry, I have to think for a second. She's teaching calculus for sure. Secondary 3, she's teaching, and um, they're still trying to decide who teaches statistics. Um, I really do not want to teach statistics, but it might be me. There's like not enough teachers, and only me and Blige can teach it because we're the only ones with the credentials to teach it. So anyway, so it's she or I is gonna eventually teach it. We don't know yet, but they are offering it, so who knows? And yeah, so I probably will not be teaching any classes that you're taking. However, I will still exist. If you want to come ask me math questions or just talk to me, please do. What was the other question they were asking? Anything? It's true, we do deserve six figures. Hmm. Yeah, I don't know. Anyway, so somebody asked what you're gonna miss next week. Oh, Eddie. Um, Next time I'm just doing the same thing as I'm doing today, which I should mention is I'm just going over your homework questions. I'm talking you through each question. These are from the ACT. So if you're not going to be able to be here on Friday, that's all it is. So you can just, whenever you're free, you can just watch the video. I always put these videos up on Canvas after I had them. After I do them. Oh my gosh, I can't talk yet. I'm trying to read and speak at the same time. Um, Yes, after we do the live stream, I always put the videos up on Canvas. So if you ever miss the live stream, all you have to do is open the video on Canvas and comment your name so that you get participation for it. Um, oh yeah. Statistics, I feel like I've done this um I've gotten on my soapbox about this before, but I really think statistics should be qualified as a science instead of a math because it's just the redheaded stepchild. Nothing, I do not. Stats is like, it's very much like a science because there are often a bunch of different answers, a bunch of different ways you can interpret data. There's a million different ways you can present the data to skew it this way and that. It's like really, it's wishy-washy, which is like, it sounds like a really bad thing, but it's just like science. Like you're discovering things and doing experiments and stuff. I just feel like it more closely matches a science rather than a math. So I am not the one that has to make that decision. So you're gonna have to talk to somebody that gets paid more than me. Anyhow, we're gonna do math now. Unfortunately, just kidding. I love math. My dog is staring up at me with like dopey eyes because I don't know what she ate, but her stomach is hurting her. Anyway, yeah, stats is if you are a math person, stats is usually difficult for people. It was for me. So, but if you're like a science-minded person, I don't know. Of course, anybody can be good at anything they decide to be good at, but that's just sort of the trend I've seen. Most people who like science like statistics. So it is very applicable to a bunch of different majors. Taking stats will count as a statistics credit, and so many majors require a statistics credit, so it is really useful, also difficult. So the guy that I taught under when I was student teaching, he taught AP Stats, and they were like at the end of the year, and I wasn't really trying, but I can tell you I was not following what they were talking about because it was all sorts of stuff I had missed in the first part of the year. So they were, anyway, it's interesting. If I teach it, I'm gonna have to refresh myself on this stuff. Anyhow, I really will, I'm gonna do this now. So, okay, number one. This is your homework as well. So if you have the capability, pull up another screen or something. So we can work through it together. You might have different numbers, but you can figure it out. Okay, a phone plan charges 19.3 cents. 0.3 cents. Ooh. Okay, so 19.3 cents per text. I'm gonna just put a T there. When it's per text, we're multiplying. For each text, we have 19.3 cents. And then $10 per gigabyte of data. So plus $10 for each gig. And then it asks what's the total cost for 730 texts and 3 gigs. So we're just plugging that in for the T and the G in my equation that I just threw together here. 730 plus 10 times 3. And then we just add those things. This calculator is slowly running out of battery, so I know one day I'm going to try to turn it on and it's not going to. 730 plus 10 times 3. I got, what did I just, $10. Ooh, hang on, pause. Okay, so I just put 19.3 cents and $10, and that should not be the case, right? So like 19.3 cents, I'm going to change it to 0.193 because cents and dollars can't be in the same equation without being adjusted to be the same thing. So now we're all the way in dollars. $10 and $0.193. I put that in my calculator and it ended up being a giant number, so that's what tipped me off because I had the wrong number. Okay, 193. There you go. That's much better. So if you do let me fix this. 0.193 times 730 plus 10 times 3, it's 170.89, which is the last answer for me. next. Number 2, oh no, I cut off all my numbers. Oh well, I think I can still do it. After Hermione starts running, her heartbeat increases at a constant rate as shown in the table below. Which of the following equations represents the relationship between her heart rate and the number of minutes passed? So this is one of the ones where we need to write a linear equation. I'm pretty sure you've had this exact question on your homework before. So the first thing we need is a slope. Well, actually, why don't we just talk about the starting point? Whenever you have an x, like a independent variable of 0, like time is usually independent, then the matching number is the starting point. Like that's where we start. If you plug in 0 and get 79, 79 is where you're starting, which means that this is the y-intercept. So in our y equals mx plus b, it's the b part. And slope comes from finding the change in x and the change in y. So slope is always the change in y over the change in x, which in this case, the y changes 84 minus 79 is 5. Y changes 5, and x just changes 1, which means that the slope is 5. Tell me if I'm doing something wrong, because you guys are good at checking my work. So that's the m part. And now we have a whole equation, y equals 5x plus 79. And look at that, it's right there. I'm sorry if I go too quickly. If you need to, pause me. It's the beautiful thing about being on technology. You can make me wait. Number 3, the cardboard box factory wants to make a cardboard box in the shape of a rectangular prism. Hey, we learned about those. With a volume of 27,600 centimeters cubed, a length of 40 centimeters, and the width of 15 centimeters. I need to draw a picture. Hang on. So a rectangular prism is just a normal box shape. There we go. And then it says a length of 40 centimeters and a width of 15 centimeters. And we want the total volume to be 27,600. To find the volume of a rectangular prism, you just find the area of the base and then multiply it by the height, which in this case just means multiplying 15 times 40 and then multiplying by whatever the height is. So the area of the base, which is a rectangle, 15 by 40, is going to be 15 times 40 is 600. And then we're supposed to multiply that by the height, but we don't actually have a height yet. And that's the question, right? We don't know, we want to know what you have to multiply 600 by to get 27,600. So I'm going to do 27,600 divided by 600 because I want to do, I can't multiply, right? Normally we would be multiplying the area of the base times the height, but since I can't do that because I don't know what the height is, I'm doing the opposite. I'm trying to figure out what the opposite operation is divided by. So we're going to divide the end result by 600 to figure out what h is. 27,600 divided by 600. 46. And that must be the height of this box. So the volume is correct. In case you're wondering, like, if you like to see algebra, the equation that I just solved was 600 times what? Well, I'll just use h. 600 times h equals 27,600 600. We're trying to figure out what this h was. And so we divided both sides by 600 and got h equals 46. There you go. Algebra is good. And here's the answer. It's D for me. Okay. Number 4 says, let me zoom in, which quadrants could the point x, y lie in if x and y have the same signs, meaning if they're both positive or they're both negative. So this one's not bad, right? We know where things are positive and negative. X is positive here, negative here, negative here, positive here. Y, so in point form, y is positive there, positive here, negative here, and negative here, which means that the only possibilities are the first quadrant and the third quadrant because those are the only ones that have the same sign. So 1 or 3 is what we're looking for, which is right there. Quadrant 1 or quadrant 3. Again, pause me if I'm going too quickly. Number 5, to increase the mean of 8 numbers by 5, how much would the sum of the 8 numbers have to increase? So this is one that we did in our stats unit. I think I remember. So the mean of 8 numbers, essentially you have some sort of sum, right? Like the total. I'm just thinking out loud here because I haven't done this kind of problem in a couple of weeks, so I don't actually remember how to do it. So we have the total of like the sum of the 8 numbers over 8, because we would divide by how many numbers of the number of numbers, right? And it equals some kind of mean. And if we want the mean, it says we want to increase the mean of 8 numbers by 5. How much would the sum have to increase? Essentially, we're saying what divided by 8 would result in 5. Because essentially we're adding something here. We're going to just put an x. And we want this to go up 5. So we can forget the things that we don't know, which is the sum and the actual mean. That doesn't actually matter because we're just trying to figure out that part with the x, which gives us this equation. X divided by 8 equals 5. Which hopefully you can see how you might solve this one. We're going to multiply by 8 on both sides, so those goes away, and we get 5 times 8 is 4. Watch me get that wrong. It's early still. Okay. Letter B for me. Give me 1 second. The principal's texting me. I might be in trouble. Okay. We'll see what he says. Number 6. Sorry. Tell me to get off my phone. Okay. How many angles in the diagram below have a measure of 50 degrees? I think we did this as a warm-up once upon a time. You can hardly see those numbers unless I zoom way in. Yes, please eat. My face was probably about getting a random text from Simon Post. Yeah. He asked me if I was home, which is weird. Like, yes, where else would I be? Okay. Supplementary angles. Add to 180, right? So this angle and 130 have to add to 180. So what does that have to be? 50? Yes. No. Yes. I need a smaller pencil. That has to be 50. And this one, we can also figure out, okay, there's a lot we can figure out here because vertical angles that are across from each other are always the same. So this is going to be 50, and that's 130. And then we can also figure out that other angle that I highlighted here because that's a triangle. And we know that triangles also have to add to 180. So 50 plus 50 plus 1 plus 80 is equal to 180. We can do that. You can do that in a calculator if you need to go slowly on that. But we need 180 total inside. Yeah, it is kind of creepy. Inside my triangle. And yeah, and now that we have that one, we know this is 130, and this is 50, and this is 130 because of the vertical angle thing. And now we need to use some alternate interior angle stuff. Remember this where if you can find like this Z shape, the corners of the Z are going to be the same. So this is also got to be 50 because the inside corners of the Z are the same. You can also find a backwards Z this direction, which would indicate that this is also 50. And then using vertical angles, we can deduce that this, I'm using that word because I watched Sherlock last night. Such a good show. Like the BBC version with Benedict Cumberbatch. I love it. Anyway, what was the question again? How many 50s are there? We have, stop moving. We have one, two, three, four, five, 6, 7, 8. There you go. By the way, I upload these on Canvas as well, just like these whole things. So if you're like, hold on, I need to see that for a second, I will upload it on Canvas. I have already the first one uploaded on there too, if you still need that one. What is the length of side A? Hey, it's trig. Yeah. Usually whenever there's angles inside of a triangle and sides, it's usually about trig. You usually should be thinking, okay, this is trigonometry. And we're wondering about side A. Hang on, I'm thinking. So, oh, this isn't a right angle though. This might have to be the like law of sines, which is something we didn't learn yet. Well, we'll learn it today. That's what this is for, I guess. One second. Let me get the equation up. I just need the equation. Okay, so the law of sines. We're learning new stuff today. Law of sines. Also trig, because it has sine in it. Law of sines. Law of sines is cool because you don't actually need a right triangle to use law of sines. Literally any kind of triangle has this property. So I'm just going to draw an arbitrary triangle here. It doesn't actually matter what it looks like because it works for pretty much any triangle. And then what I'm going to do is label the angles and the sides. So I'm going to label I'm trying to see how they labeled it because I don't know if I like it. Okay, we're going to label this angle capital A, this angle capital C, and this angle capital B. And then across from the angle that's B, I'm going to label that side little b, lowercase b. And across from the angle C, I'm going to label that one little c. And across from A, little a. The law of sines says that there's a bunch of equivalent fractions that can happen. So little a, side little a, divided by sine of its opposite angle, sine of capital A, will be the same, the equal value to little b over sine of b, which will be the same as little c over sine of c. This comes from the fact that like every side, so like the smallest side is across from the smallest angle, right? And the biggest side is across from the biggest angle. So it turns out those ratios are actually very specific, which is why this actually works. This is like ratios of side to angles that are equal. The angles and the sides being across from each other on the triangle. So notice that on our problem, we have an angle and the side across from it, and the angle, and well, hang on, we're gonna do this. Yes, there's a million things we didn't cover to answer your question. I tried to stick with the most important stuff, but as with all math, there's just a lot of stuff. In fact, infinite numbers of things. You will have learned this sometime. I think I'm trying to think when. Probably secondary 3. Most of you have taken that, right? I don't know. Anyway, so you will have learned this before. That's the idea, but probably not recently. And here we are, we're learning again. We care about this side of the triangle and we need this angle. So we're just going to use some simple geometry knowledge to figure out what that pink angle is, which is the fact that 180 degrees, all the angles inside of it add to 180 degrees. So we're just gonna figure out what's left. 180 minus 61 minus 25, 94. It's kind of close to a right angle, not really. And now we have the angle and the side across from it. And we can put these into our ratios, our equivalent ratios, and solve for what we're missing. So, so basically it's the side, which is 18, over sine of its angle, the angle across from it. And same thing for this one. Let me use colors. The side across from, or over, sine of the angle it's across from. Those things are equal. And I know that I wrote those messy, sorry. But remember that sine of a number is it's just a decimal. Don't get freaked out by dividing by sine of 94 because that's just a decimal, right? So we're going to ignore those. We're going to just pretend they're normal numbers and solve this like we would any ratio, which means, in my opinion, I think we should multiply sine of 94 on both sides so that these go away. And then we get this nice equation. Sine of 94 times 18 over sine of 61. I know that seems terrible, but you can literally just type that into a calculator, which is all I'm going to do because I'm trying to solve for how long that side A is. So I just need a number. Let me just double check that the answers, oh, never mind. We don't need the answers. Look at that. The answers are still in this form that we just already have it. So let me double check what my answer was. 18 times sine of 94 over sine of 61. So 61 on the bottom, 94 on the top. 18. I think this is the answer. We could have gotten a decimal, but they didn't need you to. Yeah, law of sines. It doesn't come up as often as you would think. It is really useful, but the stuff that we learned comes up more often. But now you have this. It's good. Okay. Number 8. Bergner's Burgers. Wow, that's nice. Okay. Makes and sells 2 types of burgers, beef and chicken. Oh, beef and chicken each day. Mr. Bergner knows that they need to make at least 190 beef burgers and 140 chicken burgers. The maximum number of burgers that can be made in one day is 420. The feasible region has been graphed below, and the objective function for profit is 170x plus $1. Wait. Oh, it's $1.70 for one burger and $1 for the other. That's cheap. Oh, profit. That's how much profit they're making. Okay, that makes more sense. Where X and Y represent the number of beef and chicken burgers made per day, respectively. Okay, what's the question? What is the maximum profit which can be made in a day? Okay. We're gonna think about this for a second. Okay, so first of all, this graph looks like a triangle, and that's because it is a triangle. But let's just think about what it means for a second. So like somewhere in this triangle, say like this point in this triangle, it means that they have made 200, okay, wait. Oh yeah, that does make sense. Okay, so they have made 250, this is chicken burgers, and this is beef. X and Y, yeah. So they have made 250 chicken burgers and 150 beef. That's what each of these points means. And the reason it ends, the reason it looks like a triangle, is that because they can't actually make any more than 420 chicken and beef burgers, both. So like after this point, they have made all chicken burgers and oh, this is just feasible. Okay, so they have made mostly chicken burgers and like a little less than 150 beef burgers. So we're trying to figure out what the maximum profit is. So they make more on beef burgers than they do on chicken burgers. No, they make more on wait, I have to make sure that I'm doing this right. X is beef. Oh, and Y is chicken. I labeled my graph wrong. That's what it was confusing me about. This is chicken. And this is beef. So these are switched, but I just misread the X and Y labels here. So they make more on beef than they do on chicken. So here's what we're going to do. We're going to calculate some profits here. Actually, let's look at the answers. That's a good tool to have. So the answers are, they range between like 463 and go all the way up to 1134. So let's look at our graph here. We know that they make more on beef than they do on chicken. So if we went all the way to where they are making mostly beef burgers. So like say let's calculate this one. It looks like they're making 250, 60, 70, 80, 280 beef and 10, 20, 30, 40 chicken. So if we plug those numbers in, if we do $1.70 times 280 beef plus $1 for 40 chicken. Let's just experiment and see what, I know the batteries are low, and see what this gives us. Plus 280 plus $1. I did plus instead of times. $1.70 times 280, $1 times 40. That gives me 516. So if we were in class, I would have us each pick a point on this triangle and look for how and see how much much profit they would make. I'm gonna try like one more point. I'm gonna try like I'm gonna try this point that I highlighted in pink with 150 chicken and 250 beef. I just want to get like a feel for how much profit they're making in sort of each range. I'm trying these numbers in the bottom right hand corner because I know that the beef, they make more on beef hamburgers, right? So it makes sense that if they made more of those and less of the chicken, then they would make more money, right? So I'm trying a couple of points and seeing what it might give me. So beef is 250 and this is 150. It might surprise you. Hang on. $1.70 times 250 plus $1 times 150. This actually makes more money than our furthest, like making the most beef burgers that you possibly can. However, we're gonna try one more point and then I'll call it because I know these are supposed to take a minute and it's been like 5 already. So because I'm persistent and I like to get an answer to these questions, I'm gonna like do one more point, but after that I'm going to make an educated guess on the answer, right? Because I don't want to have to figure out exactly where the profit is the most because I'm trying to limit my time. So I'm pretending that I'm taking the ACT, sort of, not really. So 250 beef again. And now I'm making 170 chicken. So I'm going to do $1.70 times the beef, which is $2.50, and $101 times 170, which is definitely going to be more. One times 170. I got 595 for that one. So let's look at our answers. We're slowly going up the range here. But I do not think we're going to get all the way up to $700. So for me, it would be for them to get all the way up to 700 from my numbers that I'm trying. I got up to 595 though, so that's pretty close to 616. I'm gonna go with that answer because we're asking about the most profit that they could make. And so 553 is already below something that we calculated. So I know it's not 553. And I am almost positive it's not going to get up to 1100. So I'm going with 616. Okay. I told Post I would be done by like 10 minutes. So we're going to hurry. Okay. Number 9. A function is an even function if and only if f of a negative number is equal to the same as f of the positive version of that number. For every value of x in the domain of f, which function graphed below is an even function? So even functions means that if you plug in 3, we're going to use function notation. If you plug in 3 and you plug in -3, they're going to be the same. So we're looking for symmetry, left and right symmetry, over the, what is that, y-axis, right? These need to be the same. So like f of +3, f of -3 need to go to the same thing. So I'm probably looking at maybe a parabola or something that's the same along both lines. Yikes, this is spread out over like 4 different pages. Hey, look at that parabola. Because look at that. If you put in -1, -2, you get the same value as if you get +2. Same value. Yeah? You can check the other graphs. I will let you do that if you would like to. But this is the only one that's even. Even functions. Even functions are symmetrical about the y-axis. Last one. Which of the following expressions is x minus 4 over x to the third minus 16x? X does not equal 4. Oh, okay. Okay, so they're asking about equivalence here. So the function that we have is x minus 4 over x to the third minus 16x. I'm just going to play around with this function a little bit. On the bottom, I'm noticing that I have an x in common. I'm just going to leave the top alone because we can't really do anything. But I'm noticing on the bottom I have an x in common. So I'm going to factor it out. X squared minus 16. Like that. Because if I were to distribute it back in, that'd be the same as what we started with. And then this is a perfect square. I don't know if you remember those, but perfect squares are like where both pieces are squared and then they have take away in the middle of it, subtraction, right? So you can actually factor that into x plus 4. You always have alternating signs, and then you just do the square root of each piece. I know this is a bad explanation, but go back to your notes for perfect square if you need help with that. For factoring. That's what it was on. And now we have x minus 4 over x times x plus 4 times x minus 4. And look what we can cancel. Because we have the same thing on the top and the bottom. And we are never left with a 0 when we're just dividing things. It's always a 1. So we have 1 over x times x plus 4. So what I'm noticing here is that this answer is the same as if I distributed this x in 1 over x squared plus 4x. Again, this is from the end of the ACT, which is why it's more complicated than the other ones. Both the last three, I guess. But yes, this function is the same as the original function. The thing about x not equaling 4, this bit, don't let that confuse you. The only reason they have to put that in there is because if you look at this function, well, I crossed it out, which I regret now. But if you look at this function here, if you were to plug in 4 to that function, specifically into here, you would get 4 minus 4 multiplied. 4 minus 4 is 0, yeah. And then that would be multiplied by everything else. And 0 multiplied by everything is just 0. So you would end up dividing by 0, which is the problem. So that's why they add that qualifier on there, because it's not technically allowed. You can't plug in 4 to this function, and you can plug in 4 to this function. Like, that would be fine. Plugging in 4 to this function would be okay. So that's why they have to put in that qualifier. They're not exactly the same because one you can plug in 4, the other one you can't. That's the only reason that's included. So anyway, I am gonna go because I don't know why Post is texting me. But again, if you would like to have a study session today, please let me know. I'm not gonna plan on it because I've sort of done all your homework for you, but that does not mean you can't ask because I'm around, you know? Anyway, have a good rest of your day. Your homework for last time is due today. If you weren't here last time, I did the same thing as I did today last time. I did the whole homework assignment for you, and that is on Canvas. So, yeah, there's really no reason not to have it done unless you've been, you know what I mean. It's just go find the video. I'll help you do it digitally or whatever. Anyway, you guys are great. Stay cool. I will see you on Friday when I stream then. See ya.